Welcome back to the prompting series of 360DigiTMG. So today we're going to discuss about self-reflection prompting. Self-reflection prompting is an advanced prompt engineering technique where a language model will basically generate an initial response. It will evaluate its own answer and then it uses that evaluation in order to revise and improve the responses. So it basically mimics the kind of cognitive process of how humans write, reflect, and revise their own work for better quality. What exactly is self reflection prompting? Self reflection prompting involves three core stages. Okay, so the first stage would be initial response generation, where the model is basically given a task or a question and it will generate an answer. Then the second phase is self-evaluation or self-reflection. The model is prompted in order to critique or reflect on its own output. So we'll prompt in such a way that it will reflect on its own output and think again about its response. This may involve checking completeness of the answer, identifying factual errors, clarifying ambiguous statements. Then the third phase would be refinement or revision. This is based on the reflection. The model is prompted to generate a revised answer that is clearer, more accurate, or better structured. And why exactly does this self reflection prompting even work? So, your language models like GPT or Falcon, they're not just predictive text generators, they're also trained on large scale reasoning and discourse patterns. So by asking them to reflect, what are you even activating, right? You are activating metacognition, that is thinking about thoughts itself, that is metacognition. Then in context reasoning, which is keeping the previous response in mind, and error correction mechanisms. So this often results in higher quality, more accurate, and more advanced responses from the LLM. Now, when do we actually use this self-reflection prompting, right? So, what are the use cases? So, first of all, it is complex, used when you have complex or abstract questions. It will help you ensure the answer is accurate and complete. Then, educational explanations, where in order to enhance the clarity, break down complex ideas in a better and simpler manner, or to for report writing and summary also you can use this, so you can improve the coherence and correctness of some documents. Then for reasoning and problem solving also you can use this. It will enable multi-step validation of the logic. Also for agent based tasks, so it will ensure task planning, execution, and improvement. Now let's see a few examples, right? So if I give a question saying, why do we dream? Okay. Okay, we'll get back to basically the example once we get into the code part. For now, the tips for writing a reflection prompt would be use more of a natural language. Okay. Think about or evaluate your previous answer, or ask for a critique. Is there anything missing or incorrect? Or guide to you yourself can guide towards clarity. How can you make this more clear, more accurate, more simplified version? So asking these kind of questions would help in self-reflection prompting. The technique is prompting techniques which are related to this or kind of similar to this would be chain of thought, iterative prompting, self-consistency, tree of thoughts, reflection. So the reflection framework, which came up in 2023, showed that self-reflection improves large language performance in complex decision making and agent tasks. Self-reflective agents significantly outperform standard prompt-based agents on many tasks. Let's deep dive into the code of self-reflection prompting now. So the self-reflection prompting, basically we're going to try and solve it using our Hugging Face Transformers library and casual language model Falcon RW1B. This is a detailed approach. So the first step that we're going to do is import the required necessary libraries and loading the model. So the first one is auto tokenizer or auto model for casual LM. This is for loading the tokenizer and language model. Then you have pipeline, which is a high level API to easily use the model for tasks like text generation. Torch can be used for backend tensor computations used by models internally. Then we're going to load the Falcon model. So it is a small model, basically 1 billion parameters open across model. And the pipeline, this will wrap the model and tokenizer for text generation in a single step. Then we're going to generate an initial answer. This is the first step. We ask the model a question and then we are storing the raw generated as answer as a part of initial response. Okay. Then you have reflection on that particular answer. So you're prompting the model to critique its own response. We are basically encouraging the reasoning about any gaps or any sort of clarity. Okay. Then comes step 3, where you're basically revising the answer based on the reflection, redoing the answer, rectifying the answer, or revising the answer. Say. Here, what happens? It uses both the original and the reflection in order to generate a refined final version. So here we have given your original response, and here you have the reflection response, second response, and by combining these two, it will give a refined version, final version of the answer. This will display the complete self-reflective generation pipeline. Okay, this is about self-reflection, and here, if you see the example that we have taken is, why do we dream? That is the question. So the first response was that why do we dream? The original response was so and so. We dream because we need to imagine something or it is writing some sort of theory. Then we are saying reflect, right? We in reflection we have seen this answer is partially accurate, but doesn't mention REM sleep or brain activity, which are one of the key components. So after doing reflection, it has combined the reflection and the original answer and given me a final response this way, right? Where it also talks about REM, etc. Okay, so this is how self-reflection prompting works. If I compare self-reflection prompting with COT or tree of thoughts, COT being a chain of thoughts or tree of thoughts, we can actually draw a comparison. Okay, so the core idea of self-reflection is model will evaluate and improve its own answer. Chain of thought was that model will reason step by step to reach a particular solution. Tree of thoughts is the model will explore multiple reasoning paths as a tree. The flow is also quite different. In self-reflection, it is answer, then you reflect, and then you revise. Chain of thought, you prompt, you do perform the reasoning steps, and then you get the final answer. Tree of thought, on the other hand, thought step, then multiple options, and then evaluate the best path. The goal of self-reflection is to improve output quality. Chain of thought, the goal is to improve reasoning clarity. And tree of thought is to enable strategic explanation and selection. Self-reflection requires usually 2 to 3 iterations per question, whereas chain of thought, a single linear reasoning chain is more than enough. Then you have tree of thought, which is memory intensive. It will track many paths in parallel. So what is more complex? I can say chain of thought has low complexity, self-reflection has medium complexity, and tree of thought has the highest complexity. So use cases of self-reflection, I would say answer improvement, writing explanations. For chain of thought, you have math, logic, step-by-step reasoning, and for tree of thought, strategic games, planning, and hard logic tasks. Self-reflection is basically inspired by human editing and feedback. Chain of thought was inspired by human stepwise reasoning. Tree of thought was inspired by human research thinking, like in a chess. Output again, self reflection will give you a refined, higher quality answer. Chain of thought will give you one reason answer via step breakdown. And then tree of thought, many answers. Out of many answers, it will select the best one, right? So this is how all of the three are pretty different from each other. If you combine all these techniques, you can have chain of thought with self-reflection, then you can get the you can start revising at each step. If you combine tree of thoughts with self-reflection at each node, you can do that. If you want, you can do chain of thought within tree of thought branches also. So these are the different types of self prompting techniques. Next we will look into iterative prompting technique, and then we'll start off with a couple of more concepts. I'll dig deeper into your generative AI concepts. So stay tuned. Just one more iterative prompting technique that we'll discuss, and then we can move on. Right. Thank you so much for joining in with us today. Thank you.